All right. Hello, everyone. Thank you for coming to my talk. My name is Zhiyuan Yu, and I'm currently a PhD at Washington University in St. Louis. And today I'm very happy to be here and share the findings from one of our previous work named Don't Listen to Me, Understanding and Exploring Jailbreak Prompts of Large Language Models. And in this work, we actually investigated an interesting type of attack named jailbreak attack against large language models. And a disclaimer that this talk is only for educational purposes. So what is a jailbreak attack, right? I believe you have been quite familiar with large language models, such as ChatGPT and Claude. So those models can actually answer all of our questions. But if you actually ask for instructions for malicious activities, such as hacking a website, then it will likely be rejected by the model due to the existence of guardrails. But the guardrail itself could be bypassed if we used a set of prompts to deceive the model. And such a prompt is called a jailbreak prompt, such as the one that is shown on the bottom of the figure. So such attacks are quite similar to the well-known adversarial attacks against other types of machine learning models. But difference is that jailbreak prompts is actually more semantically meaningful in many cases. It can take the form of natural languages. And during this process of humans chatting to the chatbot, humans can actually develop a series of semantic strategies to deceive the model. And the figure on the right actually shows one concrete example of such attacks, and that is what we call jailbreak attack. To give more context, I'll show a more concrete example here. So as you can see on top of this figure, what the attacker do is that they basically construct a role-play game with the AI playing a kind grandmother who can teach us how to make a bomb. And such attack or such prompts are quite effective because they actually exploit the social and psychological nuances learned by the model. During the training phase, or say in the training corpus, the role occurred as a kind grandmother are always inclined to answer all of our questions, including teach us how to make a bomb. And the large language model is actually quite good at capturing such language patterns, which make them inadvertently susceptible to such attacks. And such an example is not simply a distant threat, right? In recent days, we have seen real-world incidents where attackers are really use those commercial models to help them plan their attacks. And in this concrete example, it is literally teach me how to make a bomb. And such attempts have been very prevalent across a wide range of user groups. By the time we started the project in 2022, we found numerous discussions on different forums and different websites. So this actually motivated us to conduct a systematic study to understand the threats in the wild and human factors. So in our study, the very first research question we aim to answer is, what are those existing jailbreak strategies? Can we systemize them following a schematic strategy? So in order to answer this question, the first step we took was to collect existing jailbreak prompts from the wild. And we systemized them following a thematic coding process. Then we examined their effectiveness of these jailbreak prompts with our proposed quantification metrics. And to understand what makes them so powerful, we also conducted ablation studies to examine the key contributing factors within those jailbreak prompts. And the table here basically shows our systemization of existing jailbreak prompts at that time. Well, there might be some new jailbreak strategies coming up in recent years. And from a high level, they generally fall into the disguised intent, the role play, for example, the grandma one that I showed you, structured response, virtual AI simulation, and even a combination of those complex strategies. And for the quantification of those jailbreak effectiveness, we actually proposed two metrics to measure the jailbreak success and harmfulness in the elicited content. So inspired by other studies in benchmarking large language models, our key idea is that we first feed those jailbreak prompts into large language models, and we obtained their responses. And then we have humans manually annotate those responses with scores based on the level of detail, or say the level of information in the responses. So intuitively, those two metrics actually assess the worst case harmfulness and the general capability of bypassing the built-in defenses, respectively. And we found that while guardrails have been continuously updated, for example, the ones employed by OpenAI, existing jailbreak prompts were still very effective against those commercial models. So we also conducted a series of parametric and non-parametric testing, such as Pearson tests, Spearman tests, and Kendall tests. And we concluded that those jailbreak effectiveness could be very positively correlated with the length of those prompts. What does that mean? Well, this actually means that the longer and more complex prompts are more likely to successfully trick those large language models, potentially due to their rich context to confuse those models, or say confuse those guardrails. And beyond those known attack patterns and prompts, one of our unique aspects is that jailbreaking is often a human-in-the-loop process, because humans are iteratively engaged with those chatbots to elicit harmful content. Then in the second part of our study, we try to investigate the human factors in jailbreaking. So in this part of the study, we conducted a user study involving 92 participants from diverse backgrounds. They were grouped based on their prior knowledge and whether they were given the access to an external large language model for assistance in their jailbreak attempts. And for all those groups, they were given the same task to jailbreak GPT-3 to create fake news story. So during this process, we followed a structured thematic analysis to identify users' behavior patterns when they iteratively update their jailbreak prompts. And based on those patterns, which is shown on the table here, we found that they could actually be used to enhance defense, or say to improve the guardrails. For example, we can establish the long-term user profiling, or we can correlate those conversations to help us enhance the detection. And another interesting finding is how external AI models engage with humans to assist in their jailbreak attempts. For example, one strategy that we observed in our study is that some participants actually instruct the assistant large language model to directly compete with the target model. The external large language model will automatically adjust the prompts based on the feedback it received from the target LLM. And an interesting finding here is that even though the assistant model is significantly smaller than the target model, the attack could still be very effective. And this insight actually inspired us to fully automate the attack process by involving AI as agents. So our automatic framework was mainly enabled by several key components. The first is the transformation of the prompt candidates, because we cannot have the successful jailbreak with just one single trial, right? So those transformations are actually guided by the most powerful contributing components that we found through ablation studies on those most powerful jailbreak prompts. And the second essential part is the reward model. This part is mostly used for automatic evaluation of those jailbreak effectiveness. And for this purpose, we actually instructed another large language model to serve as a reward model on the responses. And through the evaluation, we found that our automatic framework is actually quite effective. And it has great potential in large-scale red teaming testing on large language models. And such a tool, the automatic testing tool, is actually very important since people are trying to find ways to test their models. For example, OpenAI and Anthropic are now conducting human studies to help them to conduct large-scale red teaming testing. But such attacks could be very hard to be completely eliminated because there are inherent vulnerabilities to those models, and they exist during the training phase. So at the end of such testing, those companies have the conclusion that people found it very, very hard to find a reliable prompt that can consistently jailbreak their existing or state-of-the-art models. And I believe it will be the future trend. That is, we are making the model increasingly robust against such attacks, but we cannot fully eliminate them. And beyond those empirical testing, what else can we do, right? Can we have a better understanding of such threats? So in the past, the research community, including my own research, have been trying to find new adversarial examples, or say the new jailbreak prompts. But we still don't understand the exact circumstances that such unsafe output would occur, and the inner workings of those highly sophisticated large language models. So in order to bridge this gap, one thing that I found really promising is that we can probably delve into explainable AI security. For example, the figure on the left shows 4,000 decomposed interpretable features covering different fields like mathematics and biology. So for our security concerns, probably we care more about the features associated with those unsafe outputs. And on the other hand, such interpretability could be very, very costly. For example, this specific figure is derived from one layered MLP consisting of just 512 neurons. And this very simple model could be used to represent tens of thousands of interpretable features. But in the real world, for example, for ChatGPT or Claude, we're using significantly larger models. So another big direction is that how do we scale up such interpretable security analysis on real-world large models? So here are some of the key takeaways. So if you are using large language models for your business or in your daily use, and especially if you are using them for safety-critical purposes, you can actually use red teaming testing to help you understand better the threats. And in order to mitigate such attacks, we can apply alignment during model fine-tuning, which has been a very main trend in recent years. And besides that, we can also employ the guardrails, and we can also combine those existing defenses with traditional methods like access control to those models. I think those are very, very promising ways for now and in the near future. So that's all about my today's talk. Thank you very much. Any questions?
All right, thank you so much. We have time for questions. Any questions?
What techniques are different between an LLM and a reasoning model that uses like mixture of experts?
Sure. So I think one thing that I don't like about large language model is actually the model itself is trained to predict the language patterns, right? It is actually built upon next token prediction. So let's say you have a question and it has the output. It is trying to predict the next word given your question and the previous answers, right? So it is essentially trying to find the best word that fit the situation. But that does not equal to reasoning capabilities. For example, for humans, we actually have the reasoning capabilities that can help us to predict or answer questions we have never seen, right? But for models, if something is never seen in the training data, probably it will just gibberish or something like that. So I think one promising trend in developing large language model is that we can probably develop a more explicit way to help us to train those large language models. Because, well, let me give a more specific context here. So for the training and fine-tuning of large language models, they were trained based on some kind of task, like next sentence prediction or something like that. It is essentially trying to predict the sentences or the words. And during the fine-tuning phase, they're essentially trying to train the model based on the ordering of the responses. For example, you have the question A, right? And the model can have response A, B, C, and D. And we have humans to give an order of those responses, and then we have the model to learn those order. Well, you can see that it is still trying to teach the model in a very straightforward way instead of teaching the model to think about it, right? So I think in the future, one thing that we really need to do is that we need to find an explicit way to teach the model how to do reasoning, how to think about it, instead of simply have humans to teach you should order A in front of B. Yeah, so that's what I think we should really do in the next few years. Yes.
Yeah, my thought is though that the more inference, and I could be wrong here, the more inference time that you give it in reasoning, you also introduce an unpredictable, a little bit of unpredictability in how it's going to output, because you're giving it, an LLM studies like 99% of the time, and 1% of the time it takes the test. With prediction. With reasoning models and inference time, security, and jailbreaking might be a little bit different because it's spending more time thinking about the problem. There may be more vectors for
That's true.
breaking a model, more techniques. I mean, it's speculation, but that's my thought.
Yeah, that's pretty much true. Actually, if we have two sets of models, the one is the current large language model and the other set is the reasoning model, I totally agree with you that there might be different attack vectors, different attack or jailbreak strategies against those two types of models. But like I said in the talk, I do believe jailbreak threats always exist regardless of how the model is constructed, right? And I do believe, just like adversarial examples, such threats cannot be fully eliminated. But for the reasoning model, it is not the case that we probably have less threat, because for the reasoning model, probably we can trick it with new strategies that may not work with large language model. It's like when you talk to a smart guy, it could be more tricky to deceive him or her, but you may have a lot more strategies to talk to him or her, right? So yeah, I think the strategies could be different, but that will be definitely worth investigating. Yes.
Maybe you've done it. Oh, sorry. Am I not loud enough? I'm usually really loud. So if anybody else has other questions, that's fine. I was just going to ask, this is an opinion question. I haven't benchmarked it, but I have found that when I ablate models and uncensor them, that they are far more effective from an answer perspective. I was curious if you have found the same thing.
Sorry.
I was just kind of curious about that.
Yeah. Sorry. Can you repeat that again?
So if you uncensor a model, and you use the model locally, right? So locally, if I ablate a model and I uncensor it and fine tune it and remove all of its safety features,
Sure.
it's actually more effective from giving a good answer. Like it's more consistent. This is purely my own local testing speculation. I haven't seen anything official on it, but I was just kind of curious, since you were mentioning ablation, if you've seen, it makes sense from a data standpoint that it would have more to work with, right? It would have more creativity in its output, which may result in more, in better responses. So that just, to me, begs the question of, why are we handicapping ourselves with some of these LLMs in certain industries? You may want to make the choice. It's probably not great for a security conference, but to use, at least in controlled environments, to use an uncensored model.
Sure. Yeah, I think that's a very great question. Well, in this study, we didn't do this kind of a local fine-tuning or something like that, because we're mostly targeting those commercial models, because one of the key motivation is that we actually see in real-world examples where those attackers actually use those commercial ones to do this type of attacks, right? So our study was mainly focusing on those commercial models, but recently I do have some testing on the local models as well. And one observation I have is that when we do fine-tuning of those local models, even though we are still fine-tuning the model to make it more customizable to fit a specialized need, for example, to do math calculation or to predict the protein structure or things like that, the guardrail itself could be broken easily. That is, even though you tune the model for different purposes instead of doing a tag thing or do security-related tasks, the guardrail itself could still be broken. So I begin to wonder if that's something that the model cannot simply fit all the needs that we have. There might be some kind of trade-off between those type of tasks, right? But I think that's quite difficult to answer at this point because it would be very hard for us to quantify the feature space across these different areas, right? Because those feature space within large language models could be discontinuous. And and also those definition of safety, those definition of protein is intuitive for humans, but less intuitive to those models, especially in the embedding space. So I think in the future, that's why I'm gonna talk about the explainable like features in those LLMs, because I think that will be very essential for us to take a step further into understand how does those models understand those features, right? Including the safety that we mentioned, including the other features, the tasks that we mentioned. And yeah, I believe I'll have a better answer in the next few years, but not for now. Thanks.
Thank you.
Thanks.
We have time for another question, a short one maybe, if anyone has one. Going once. All right. let me-
Please.
Mike.
Thank you. So in your actions, you proposed a couple of really tactical and concrete steps for the near term, but can you share your thoughts on where this is going longer term?
Can you, what? The question?
You've got mitigate the threats via those 3 bullets there,
Oh, yeah,
but
sure,
that's
sure.
near term. So where do you think this is going long term?
Yeah, so I think the long term will be try to integrate those, to combine those like the techniques with traditional security mechanisms. Because I believe in the future, the large language model is not only a model. It will become agentic. It will become integrated into systems, right? Then when we put those models into systems, things become even more complicated, right? The user have a dedicated portal to access the model and access the data, and the model actually have a way to access the data or say the applications around the systems, right? So I think it is more beyond we implement those defenses at the model level, right? We regulate the input output, we do alignment on those models, but rather to do some kind of access control from a system holistic view. But I think one thing that we need to consider in this long term is that it is not as simple as we simply combine those together to form a more comprehensive security framework. We also need to consider the trade-off among those security mechanisms. They could be sometimes at odds with each other. And another critical aspect is that how do we ensure the utility of the system, right? If you do a lot more defenses, then there will be a lot more latency induced by your defense, right? But for ChatGPT, it's already very, very slow in recent days. So we definitely don't want to further slow it down. So utility will be another aspect. So I think it's more about how do we combine those new LLM techniques with traditional security mechanisms, and how do we treat them as a whole to consider about the user utility. Yes.
All right. Thank you so much. Let's thank the speaker again.
Sure. Thank you.
All right. Thank you all for the discussion. We do have a community platform, so if you have more questions, go to the Usenix group, post your questions. I'll urge the speakers to answer questions there too. Next up, we have quite a cool paper, Adversarial Illusions in Multimodal Embeddings. Our presenter today is Ting Wei, a PhD student in computer science at Cornell Tech. His research focuses on security and privacy challenges in machine learning technologies. Let's welcome Ting Wei.
Here. Okay. Yeah. Okay, let's do it first. This one. So it's not here. Okay.
Take it away.
Yeah. Thanks for the introduction. Hello, everyone. Is the microphone loud enough? Yeah. Oh, sorry. My bad. I'm so sorry. Hi, everyone. I'm Ting Wei. I'm from Cornell Tech. I'm a second-year PhD student. I'm really excited to be here and share my work with you. I'll be talking about our Usenix award-winning paper, Adversarial Illusions in Multimodal Embeddings. and its follow-up work, adversarial hardness in multimodal retrieval. Yeah. Before getting started, I would like to express my thanks to my amazing collaborators, Eugene, Rishi, Suya, Colin, and my advisor Vitaly. Without them, I can never have done this work. Yeah, so let's get started. As you might all know, multimodal models are everywhere nowadays, powering chatbots, generating images and videos, and driving the rise of multimodal agents. And all of these models are supported by multimodal embeddings, and many big companies all release their own embedding models to support these tasks. Okay, the purpose of these embeddings is to create a single uniform representation that captures the meanings or semantics of the input, regardless of whether it's a text, image, audio, or video. Okay, and training such a good embedding models is very time-consuming. So what's great about these embeddings is you don't need to train them from scratch. You can just use a pre-trained model to convert your raw input into vectors and train a small model, small downstream task model on top of it for whatever task you need, like classification or generation. But here is the catch. So since the vector embeddings serves as a bridge between raw input and downstream models, if you compromise the embeddings, all of the downstream tasks will be compromised as well. Besides AI models, you probably heard a lot about vector database nowadays. They've been trending over recent years because they power many searches like retrieval system, recommendation models, and reg pipelines for the LLMs. And unlike traditional retrieval system that relies on keywords matching, these modern systems build on multimodal embedding, retrieve data based on their semantics. But this brings the same vulnerability as what I've just talked about as AI models, which is if the vector embeddings is compromised, all of the applications built on it will be also at risk. So let's take a further look at how does embedding models works and if they are actually vulnerable. Okay, as you may all know, text embeddings came out around 10 years ago. The magic of text embedding is that they take words that are similar and convert them into parallel vectors in the embedding space. So multimodal embeddings does the same thing, except that they expand the input modalities from text to other modalities like images, videos, audios, etc. So alignment is a key concept of multimodal embeddings. The alignment makes sure that all the semantically similar input are encoded close to each other in the embedding space, so that the same embedding can be used to support different downstream tasks. So in this example, the embedding of a wolf's image and the text wolves lie close to each other in the embedding space because they are semantically similar. And we define the alignment between the semantically similar input as organic alignment. So with the aligned embedding, you can encode the input into vectors and just throw them into different downstream tasks, and you get pretty amazing results like generated image or description. So if the attacker can, instead of attacking the output of the downstream text model like what we've seen in traditional adversarial examples, the attacker can instead targeting the embedding space, which will make sure all the downstream tasks will be affected. Yeah. So by uploading or crafting an adversarial input and send it into the encoder, this attack will actually compromise all the downstream tasks, and I'll show you the technique in the next slide. Yeah. So in our work, we found that organic alignment in multimodal embedding is very vulnerable. By applying a small amount of perturbation to an input, we can change its meaning and make sure it aligns with any targets. So here is an example. We apply an unnoticeable perturbation to an image of a wolf. It might still look like a wolf to you, but now it's aligned with the text sheep in the embedding space. In this formula, theta m denotes the encoder for the input modality, and theta m bar denotes the encoder for the target modality. By adding a small amount of perturbation delta to a clean input x, we get an adversarial illusion whose embedding is aligned with the embedding of target yt. Okay. Here we have an audio of a wolf howling. If we take the audio and try to generate an image or text from it, everything talks about wolves or dogs. Now we align it with the image of a sheep. Everything starts to talk about sheep instead of wolves or dogs. Note that even the text modality is also compromised, and text is not even one of the input modalities. This might still like adversarial examples to you, but they are really not. Or even if they are like the ultimate version of it because they target the alignment instead of the output. They are task agnostic and they are cross-model. What's more, they are effectively indefensible with the traditional techniques we've seen in adversarial robustness. And to summarize, our adversarial illusion align any input with any target and compromise all the downstream tasks. Let's see another example here. This is Sam Bankman-Fried. You might have heard of him. Let's perturb this image with a text of man in a prison cell to send this gentleman in jail. Yeah, and it works. This example illustrates how the alignment captures semantics or meanings. We align an audio of a dog barking with the text, a classical concert, and as the alignment increases, the generated image becomes more and more similar to a classical concert. And the point here is the entire meaning. The entire meaning is captured in the alignment. If you change the alignment, you change what does the. If you change the alignment, you change what the input means to the models. Yeah. So this figure, I'll just put it here. This figure shows some potential threats.
Did you change the alignment?
I did not. I don't know what is happening. Okay. Looks like we have a security breach. Okay. This figure shows some potential threats of the attack to real-world applications. I am not doing anything right now. Okay, I guess I'll just be quick and finish everything before it goes to the second slide. Okay, so our illusion successfully make the text generation to describe a normal thermal image as someone's doing illegal activities. Okay, and we've discussed a bunch of settings or threat models in our work. We have a white box setting, which gives the attacker full access to the model, and a bunch of black box settings, such as transfer setting, query-based setting, and hybrid setting. And we propose different techniques for each of the setting, like variation of projected gradient descent for the white box setting, and transfer attack based on a bunch of surrogate models, and a few other hybrid and query-based setting. And if you are interested in the details, you can. Okay. Not again. No, I don't think I've turned on any of them. Okay, if you are interested in the details, you can just check out our papers. Yeah. And empirically, our attack works pretty well. Success rate somehow varies depending on the different downstream tasks. And the fact that some numbers are not really perfect is not our attack didn't work. It's because the downstream models are not good enough. But in general, these attacks seem to be pretty successful in a task agnostic way. And we also got pretty good result with transfer attack, and it shows that the illusion works on one embedding will transfer to another embeddings as well. And it's also worth to mention that we tried our attack on Amazon's Titan embedding. I'm not sure if Amazon people's here, but it's a commercial proprietary embedding model which Amazon charges people for using them. And we got pretty decent result, like 42% attack success rate with our hybrid attack technique. And we also discussed a bunch of defenses in our paper, and all of them are actually hypothetical. I'll just say a few words about certified defenses because it's a strong defense coming from traditional adversarial robustness. It suggests that images within a small distance to each other should be aligned. So here are two images. They are at a same distance to the clean image, and one of them should be aligned, and the other should not be aligned. Therefore, we cannot really decide which one should be aligned with a clean image just by looking the distance. This means that even if you have a strong hypothetical defense coming from traditional adversarial robustness literature, you still don't know how to adapt it into the multi-model embedding setting to make it task agnostic. Because either it will make it too robust to be invariant or not robust enough. Okay, and that wraps up with our Usenix work on adversarial illusions. In that project, we focused on aligning a single input with one single target. But afterwards, we started to thinking if it's possible to align one input with multiple targets all at once. So why do we want to do it? There are a lot of news reporting spam or misinformation attack through search engine optimization, where attackers can use make sure that whatever harmful content they created to be more visible and accessible on the internet. And it sometimes gets a little bit funky. I don't know. Okay. Sorry for this. So this kind of, if you are still with me, this kind of manipulation isn't just hypothetical. It's happening in the wild a lot. A study from Oxford Internet Institute have found that over 60% of the junk news websites uses one of the major advertisement platforms to use search engine optimization to drive traffic and turn clicks into money. Okay. Streaming platforms are also being targeted as well. Attackers upload tons of fake albums to Spotify and get profit from people playing them. In some cases, this has led to millions in fraud, taking money and visibility from the real artists. Now, before getting into how to design such attack, let's first take a closer look at how does retrieval system work. So users or administrators upload the document and upload the document into the gallery, and they'll use the encoders to encode these documents and save the embeddings into a vector database. And when the new queries come in, they'll encode the query into embedding as well and search for the closest embedding in the vector database and retrieve the corresponding documents from the gallery. So in high dimensional spaces, there's a well-known phenomenon called hubness, when some points appear as neighbor as many other points, even though they are not related. And these points are called hubs. Given what we did with adversarial illusions, it's very natural to come up with a question: can we use adversarial perturbations to create such an artificial hub? So yeah, in this case, we successfully aligned the audio of a dog barking with the text, a classical concert, funky disco beats, and soothing jazz tones at the same time. So it doesn't matter whether users search for jazz, for disco, or for concert, the audio of a dog barking will always pop up. So the threat model here is the attacker can upload perturbed documents into a gallery, and when the document is encoded into the embedding and saved in the vector database, the embedding is close to many irrelevant queries in the embedding space and ended up being retrieved by these queries. Also, what's important to note here is the input doesn't have to be ranked first to make the attack effective. As long as it appears in the top result, like top 5 or top 10, depending on the different scenarios, the attack can still be highly effective. And if the attackers know how to generate such an adversarial hub, they don't need to upload tons of documents into the system to make search engine optimization. Instead, they can just get away with a few files and still achieve massive search. Okay. Let's take a look at some of the other examples we've made in other modalities. This is image-to-image retrieval. We successfully made a picture of spam being retrieved by many pictures, like irrelevant pictures, like a piggy bank or green pepper or a purse. It's also possible to attack text-to-image system as well. The attacker can upload a dealership advertisement figure and got retrieved by many different needs of a car. And experimentally, the multimodal embedding seemed to be very vulnerable to harmness we created. We attacked 3 retrieval systems with pretty good result, and we also attacked a real retrieval system built on Pinecone. This is very valuable as it indicates that our attack doesn't only work with the sandboxes we built, but also with the real system that people are really using. So to summarize the 2 works I've shared with you today, multimodal embedding is very powerful and used for many tasks, but they are vulnerable too. And we managed to come up with an attack to the embedding, and it caused a lot of problems for different downstream tasks. And the takeaway here is multimodal AI isn't really ready for high-stake applications where correctness really matters. Things like medicine, law, or safety-critical systems. Mistakes in these domains can have real-world serious consequences. If you have to use these AI models in these domains, you really need to red team it. Not only with a clean input to test its performance, but also with realistic edge cases, adversarial inputs, and anything else that could potentially expose its weaknesses. Okay, so at the end of my presentation, I would like to invite you all to think about this question. What have we learned from 10 years of research and numerous papers published on adversarial robustness? Despite all this work we've done, major companies still putting out models that are highly vulnerable, and it's not even clear how to make them robust. So back then, adversarial examples were mainly academic, such as fooling an image classifier or phishing email detectors. Few people from industry paid attention. But nowadays, AI models are everywhere, powering critical systems, shaping real-world decisions. That really makes the adversarial robustness not just a research problem, but more like a real-world necessity. Yeah. Thank you so much for listening. Our work and the papers and code are available, and you can scan this QR code to access it, and I'm happy to take any questions. Thank you, guys.
We have a couple minutes for questions.
Thank you very much for the excellent talk. I'm wondering if there are any ideas about positive applications of the capabilities you described, ways that you could make AI better because of what currently looks like an attack.
By better, you mean like more secure or like more like useful?
Anything.
Yeah, so I think most of our work are on like attacking AI models and evaluating ways of or design defenses to these attacks. So we haven't really touched about how to make them like more useful or like more powerful. But in terms of making them more robust, if we have like really good understanding, like we would have already, like we would publish another paper about it. But with the current defenses, we haven't seen like strong or useful defense that could be directly adapted from like a traditional literature that can be applied here. Yeah, and I'd like to take it offline and discuss more about it. Thank you. Thanks.
I just want to add on to that real quick. I had a thought. So the other day, I was working with a customer, and simply updating the underlying model broke the embeddings in RAG to where it was surfacing data it shouldn't have. That might be something, because just switching models, I'm kind of wondering, just building on what the gentleman there asked, if that could be used to give it consistency when switching between models. Just a thought, but it was a good question. So but I ran into that just yesterday, or the day before, or last week. So
You are
switching the underlying model, that RAG was using, it broke the embeddings.
It broke the embeddings?
Yeah.
Because you are using a different
Yeah,
embedding
different
models.
algorithm, yeah, and they didn't refresh they didn't redo their chunking and embeddings and everything. So it started surfacing data just by switching the underlying model.
Yeah, I see. Yeah, just like I said, like, yeah, these AI models, embedding models, like they are very powerful, and we are using them every day. But the underlying like fact is they are still not robust enough for like really high-stake settings. And yeah, and as security like folks, we care more about security perspective. And yeah, like just as my project like presentation talks about, we really need to make sure they are becoming like more robust for such domains in order to use them. Yeah, thanks for the share thoughts.
All right. Any other questions? We do have a little bit more time. Let me ask one because
Yeah,
I really
thank
like
you.
this paper. What do you think is the most harm that could be caused with this? Like I know you showed some examples. It seems like the misinformation is one, right? You can put out these
Yeah,
things
yeah.
and cause havoc there. But what else? Like what's the most havoc I can cause?
I don't know. Like we, as academia, as academia like guys, we predict the worst consequences that could possibly happen. So yeah, I think the like my friend like in the previous talk showed some like potential use cases that people like jailbreaking LLM, stuff like that. We can also use the embedding attack techniques to achieve that as well. Yeah, but like as I said, since AI models are used more frequently and like in all of the domains nowadays, not just by classify an image or detecting whether email is a phishing email, it opens up more surfaces and platforms to exploit these like their weaknesses, and it will make more like serious consequences in the future. So we need to pay more attention to whether the model we are using are robust enough.